Because normally, you see, the thing with math, it's actually quite a lot of pattern recognition. That's actually what math is. If math was called pattern recognition, it wouldn't be something crazy. But anyway, so it says calculate the sum of the digits of the number this. So funny enough, questions like these, right? Normally you will find out that this number will literally have a scenario where it maybe even has a few values, maybe like a 1 in front here and a bunch of zeros. So the sum of the digits would even maybe be like 1, because it would be like 1 plus a bunch of zeros. That's usually like what you can expect from these kinds of questions. Because what is the marker location for this question?
The marker location is 4.
4, you see. So for those 4 marks, they actually want us to see how this number is going to look like when it is like drawn out. So you see, like something like 2 to the power of 2015 and something like 5 to the power of 2000 and what is this, 2020 2019. Clearly those are very huge numbers, like mega. So we actually have to be a bit creative. And the one thing that I am thinking of is things like exponents. Because the only way you can link up these two, right, since they're being multiplied together, one thing that comes to mind is having exponents that visually look the same. Of which here, the only way that we can have exponents that will look the same is if we write this in terms of 2015. So here we have 2 to the power of 2015. This one we can write it as 5 to the power of 2015 plus what's that thing? 20 it would have to be 2004. So if you look nicely here, right? Do you see what we just did? We just broke up the 2019 to 2015 and 2004, because that's like a common way to deal with huge numbers. When you see your exponents are too big, focus on them, because they are the ones with the bullseye. So here now, what you can actually do is if you like, let's say, split up this to have two bases that look alike, we know that this is what we're going to have, right? Because technically, if your bases are the same, you would add the exponent. So here we're like going in reverse, you see, split it up, and then here the bases. So that now these two, you can easily see that, okay, wait, there's a way we can link these two since the bases are.
Can I ask?
Yeah.
I have a question. Why is your 5 like the last 5? Why is it 5 to the power of 2004?
Because 2004 plus 2015 is what gives us 2019.
Really?
Yeah. 4 plus.
Is it
Oh, no,
4
no.
though?
It's a 4. The number 4. Oh, dang it. No. Whew. Yo, okay. Yeah, it was awkward. And they say it's so confident. I was like 2015 plus 2004 is 2000. Oh, lol. Ay. Oh, life is a joke. Well, this actually makes our life so much easier, actually. Yeah, anyways, my mind was somewhere else. Yes, this is a 4 and this is a 4 as well. So clearly one of us is awake. The other one is still snoozing, still in dreamland. So yeah, it's a 4. This actually makes our life so much easier, because in my head I was thinking, wait, what? 2004? But it was subconscious, but I just kept going. But thanks. So yeah, you see now it even looks more colorful, because these two, the exponent is the same. So this you can write it as 2 times 5 with a single exponent up here. Now this is useful to us because now this is a number we can write out if we need to, but then this now allows us to see that, okay, this is just a 10, and 10 to the power of 2015 is a number we can easily visualize. And then the number 5 to the power 4. Remember, this is 5 times 5, 4 times, you see. So technically, I mean, this number, we don't have to struggle for it. We can actually use our calculator. You see, remember, this question did not say don't use a calculator. It didn't even have to say don't use a calculator because you can't anyways. The number is just too big. You can't put this in the calculator. But then this 5 to the power 4 here is 5 times 5, which is 25. And then times 5, which is 125. And then times 5, which is going to be 625, if I'm not mistaken. But then I don't know why I'm not just using the calculator, because this is just a risky business, and there's no need to do risky business when you have the calculator. So in as much as I'm thinking, yeah, that's fine, let me actually grab the calculator here, and is confirmed, 5 to the power of 4, 625. So are we still on the same page? 625, I mean. Are we still on the same page? Your call has been placed on hold. Please wait. Your call has been placed on hold. Please wait. Oh, looks like we lost our, our participant. But anyway, since this recording is still going on, I'm just gonna carry on for now, right? And then finish. And then I'll just hit it up later and see what happened. Or not later, just now. I'll hit it up just now. Or let me actually just pause and see, where our fallen comrade has gone to. I will be his back. Hold on. Hold on.
It converted the 5 to the power of 4 to 625. Now, my question was, what is the sum of digits? I don't understand how to get the sum of digits.
Okay,
Yeah.
so they just mean adding up the numbers in the number. Huh? So for example, right, if you have the number 2000, the number 2000, the sum of the digits here is 2 plus 0 plus 0 plus 0,
Oh, okay.
which is just 2. You see, so if you add the number 2001, then you would add up numbers from 2 to, you'd add up 2 plus 0 plus 0 and then plus the 1 there. It would give you a 3. So that's the sum of the digits.
Oh, okay, so I can do that for the 6 to 5. Now, how do I do that for the 10 to the power of 2?
Yeah, you see, this is where things get simple, because remember, you have to visualize what 10 to the power of 2015 would look like. So the easiest way to do it is, remember, 10 to the power of 2 is just 1 with 2 zeros. 10 to the power of 3 is 1 with 3 zeros. So 10 to the power of 5 would be 1 with 5 zeros. So do you see that it doesn't matter what the exponent is here? The sum of the digits will always be 1, as long as this is 10. Because if it's 10 to the power of 100, we know it's a 1 with 100 zeros. So if you add 1 with 100 zeros, your numbers will still just add up to a 1. Do you get it?
Okay.
Yeah. So with 10 to the power of 2015, we know it's 1 with literally 25 zeros. I mean, 2015 zeros. You see? So, I mean, like if you think of 2015 zeros and you add up with 1, the sum will still just be a 1 only, because 1 times a bunch of zeros is just 1, right? Yeah. So here we can say that obviously the sum of digits is technically going to be a 1 for this whole thing. Is just going to give us a 1 plus the 6 here plus the 2 plus the 5, which is just like 3 here plus 5, which is 8. 8 plus 4 plus 6 gives us 14. That's your number.
Yeah. Oh, okay. Thank you. I think the memo is wrong because the memo wrote 13 for some odd reason.
30.
13.
Well, we can always just double check what we wrote, because
No, I think you're right though.
1 plus 6 plus 2 plus 5. Yeah, it's 14. So awkward. 2015 1 plus 2015 zeros. Yeah, the answer is 14 there. But then if the memo says 13. I mean, but I don't know why. I think it definitely has to be 14 there.
Yeah, I
Because
think they
two
left
two.
out the one.
Oh yeah. Yeah. So that's that. But then normally, if this is from the blue book, then we might want to look a bit longer, because normally the blue book, it's very rare, you know. But we can look a bit longer, like a second or two.
Maybe
But
let me
yeah.
check if let me double check because maybe I said it wrong. 220.
Why did I write it 3? I meant to write it 3. 1, 2, 1 plus 0 plus 0 plus 0 is 3. Yeah, this is just
Yeah, the
maybe
blue
a
book
1.
said 13.
13. What a wow, man. What a wow.
No,
That's
I
very
think they made a mistake.
that's very unlike the blue book. But okay, I guess we'll have to take our win then. It's definitely a
Yeah.
14 there.